almost there. This one we're given a rational function, right? And we're asked to find the asymptotes, both the vertical and the horizontal. So vertical asymptotes, excuse me, start with that. Where vertical asymptotes come by or happen is when the denominator equals 0. So all we do for the vertical asymptotes is we take the denominator and we set it equal to 0. This will tell us where the vertical asymptote will be. So we solve this for x, subtract 9 from both sides, we get 2x equals negative 9, and then we divide by 2. So x equals negative 9/2. That's going to be a vertical asymptote. Okay, and I guess maybe before I start off, always good to take a look at the graph. So I'm going to show how you can graph this. Go to y equals. If you go to the alpha, that's your green, anything in green on this calculator, and the F1's in green. Kind of have to remember this, but if I do alpha F1, it gives me the fraction template. So if I do that, I get a numerator and a denominator. It's just easier to enter everything. Again, that's only if you have a newer, say in the last 10-year operating system, TI-84, and you can update your operating system. If it doesn't do this, we can do that. A TI-83 will not. You can't update it anymore, at least not that I'm aware of. I've tried, that's how I remember it. But anyway, here it is, 6x plus 13, 2x plus 9. Otherwise, you're going to need to use parentheses around the top and the bottom to make sure it graphs correctly. So you would have entered it in as 6x plus 13 with parentheses around it, divided by parentheses 2x plus 9. That will get you the same graph. So we're going to go to a zoom standard, just as a good place to start. And you can kind of see it. Okay, it goes there and there, and it looks like there, somewhere in here is where there's a vertical asymptote, and that's at 1, 2, 3, 4, maybe somewhere between 4 and 5. Negative 4 or 5. Negative 9/2 is actually negative 4.5. So that looks like, yeah, that's about where it's at. Okay. And I think, let's see, we can draw a vertical line. Let's put that in there. If you go there, we can move it over. You can kind of see that asymptote. You can get to negative 4.5. I don't know if we can exactly get there. Can we enter? No, we can't. But that's the idea, is you would have that vertical line there. So let's go ahead and put that in there. So the vertical asymptote. Here we get the vertical asymptote. We have to give a point. Remember, this is x equals negative 4.5. So x is going to be negative 4.5, or since we solved it, a negative 9 over 4, over 2, sorry. It's right there, negative 9/2. And then for your y value, since it's a vertical line, any value will work. Let's do 27. It's going to be off there, 5, 6, whatever you want to do, negative 3. And you get that vertical asymptote there. Draw it. That's the only one there is. And again, we could kind of see it there. And then you can see also a horizontal asymptote is going to occur somewhere in here. That looks like maybe at about 3, maybe 4, 3.5. I'm not quite sure. The way we're going to figure that out is the vertical asymptotes. There's two things it could be. It's either going to be 0 or it's going to be the ratio of the coefficients. Now, whenever the degree of a polynomial is the exponent on the x, this is x to the first power, x to the first power. Whenever the degrees are the same in the top and the bottom, what's going to happen is the horizontal asymptote is going to be the ratio of the coefficients. So this will be like 6 over 2. which, and it's horizontal, so it's going to be y equals 6 over 2, which is y equals 3. And you can see that 1, 2, 3, that looks like about the place where it would be. And if you want to even see it better, you could actually put in y equals 3. I'll show you, you can actually even put it in as a dotted line. We go here, let's see, how do we do this? Enter, it's going to be red. Let's see, we can, there, a dotted line. Okay, go to the graph. Well, that doesn't look like a dotted line to me, but okay. So that would be the horizontal asymptote. And that looks about appropriate, right? And so we come here for our horizontal asymptote, we get that. The y coordinate is 3. The x can be anything we want it to be. How about 0? If I get too worried about, oh, I didn't want to point. But I guess I would, oh, I went there. I shouldn't have gone there. Let's erase that. I guess I could use that, but I want the horizontal asymptote. I thought that's what I had. So I'm going to put in 3 for the y. X can be anything I want. I'll put 0. And there you get your horizontal asymptote. Okay, so that's all there is to this. There is not another one. If we had a square in the denominator or something, maybe we'd get 2, but we don't. The other thing that could have happened, had this been given to us as just like 13 over 2x plus 9, then notice the numerator, the top, its degree is smaller because it's really x to the 0. Its degree is smaller than the bottom, and so that means that we're going to get a horizontal asymptote at x equals 0. So don't forget that one. When you only see something with just a number in the numerator, we're going to get y equals 0. That would have been it. But this time, we've got an x in the top and bottom, so it's going to be the ratio. Always, if you can, graph it, and it will give you the indications of where those asymptotes are at. Okay. Sounds good. That's number 11. One more to go.